In this video, we're going to see how to use StatsKingdom to run a hypothesis test on a population mean. So here it says test the claim that the mean GPA of night students is smaller than 3.22 at the 2.5% significance level. Okay, null and alternative hypothesis. So anything with a P isn't going to be correct because P is proportion and we're testing the mean GPA. And so we definitely want our H naught, our null hypothesis, to be mu equal to 3.22. But I don't think we want not equal to. It said smaller. So we want to find the less than one. I don't see that. Actually, all I see is this one. So it looks like this is the only one that could work. So it is okay for the null hypothesis to use a greater than or equal to or a less than or equal to. As long as there's an equal to as part of it, that's okay. Okay, so this will work right here. Though I probably am going to think of the null hypothesis as being equal to 3.22. Okay, so this test is right-tailed, two-tailed, left-tailed. Since we want to test whether the mean is less than 3.22, that's left-tailed. Okay, based on a sample of 45 people with sample mean GPA of X bar equal to 3.209 and a sample standard deviation of S equal 0.096. Here's our sample value, and then they want us to put the p-value in and then state whether we believe we should reject the null or fail to reject the null. So if I go ahead and look at StatsKingdom, and if you go to StatsKingdom.com, we have a bunch of tests here, but we're looking at just one sample, and we have to decide, do we want the Z test or do we want the T test? And it's really nice. It actually tells you, if you mouse over it, what the conditions are to use these different tests. And if I look over here, I can see, sigma, that's our population standard deviation. Do we know it or do we not know it? I believe they did not give it to us. Let me see though. So this is sample stuff. Yeah, they did not tell us the population standard deviation, so we need to do a t-test. Okay. So first is tails. We are testing the claim that our mean is less than 3.22. Our significance level is, where'd it go? Oh, up here, 2.5%. So that's going to be 0.025. Our expected mean is 3.22. We'll leave it at 4 decimal place for rounding. We're not going to worry about this stuff, just leave it, all of this right here, kind of as it is. So now we're going to come down here and put in our sample statistics. So I'm not going to name this. Our sample average, X bar, was 3.209. Sample size, 45. And sample standard deviation was 0.096. Now they did give us the raw data, so we could have copied that data and put that in. I should go ahead and put this standard deviation in before I forget it. So if I put enter raw data directly, I could copy and then paste it in right there, and it would calculate this stuff. So calculate. All right. And it gives us the last thing we're supposed to determine first. It actually gives us the punchline first. So our p-value, it says, is greater than alpha, therefore H naught cannot be rejected. So let's see what the p-value was. Okay, here it is. So it's kind of big in some ways, 0.2231. So let's see how many decimal places. 2 decimal places. And it doesn't say percent. So let's assume we're doing the decimal, so 0.22. And so since this is larger than our significance level, our alpha 0.025, we fail to reject the null. So let's see, there we go. So this was running a hypothesis test on a population mean when our population standard deviation is unknown.